Which of the following is true about the function f if f of x is equal to x minus 1 squared over 2x squared minus 5x plus 3? 1. F is continuous at x equals 1. 2. The graph of f has a vertical asymptote at x equals 1. And 3. The graph of f has a horizontal asymptote at y equals 1/2. This is a tricky problem because we have to go through all of these steps first and then select the answers based on what we find out from here. So let's start with number 1. So I moved the function over here, and what we're trying to determine is whether f is continuous at x equals 1. In order for this to be true, 3 things need to be happening. 1. F of c must be defined. 2. The limit as x approaches c of f of x must exist. 3. F of c must equal the limit of f of x as x approaches c. Okay, so we're going to work that out over here. You can still see the function over here. And what we need to do is plug 1 in, because we're trying to see if it's continuous at 1. So we're going to do that right here. When we work this out, we end up with 0 over 0. Whenever a function is divided by 0, that means it cannot exist. Therefore, the first requirement is not true, and that means number 1 is false. The next step is to determine whether number 2 is correct. Number 2 says the graph of f has a vertical asymptote at x equals 1. In order to determine where the vertical asymptotes are for this function, we need to set the denominator equal to 0. In order to do this, we must factor. The first 2 coefficients must be 2x and x because when multiplied together they will make 2x squared, like this equation. Next, we're going to do the factors of 3. We're going to do 2x minus 3 and x minus 1. The way we can make sure this is correct is by foiling it. So we're going to end up with 2x squared first, inner minus 3x, outer minus 2x, and last plus 3, which of course ends us with 2x squared minus 5x plus 3. So, because these are our factors and they're equal to 0, we're going to end up with x equals 3 over 2 and 1. Now you may think that this means there's a vertical asymptote at 1, but actually, if you go back to the numerator and you factor that out, you're going to end up with x minus 1 times x minus 1 over 2x minus 3 and x minus 1. These cancel out, which means there will be a hole at x minus 1, not a vertical asymptote. The only vertical asymptote this graph has is 3 over 2. Therefore, the graph of f does not have a vertical asymptote at x equals 1 and is incorrect.
You would think, since this is the last one, you should circle C and move on. But in fact, you should double check to make sure. Let's see. Number 3, the graph of f has a horizontal asymptote at y equals 1/2. First, FOIL out the numerator. X minus 1 times x minus 1. That's x squared minus 2x plus 1 over 2x squared minus 5x plus 3. Our coefficients both have x squared. Using the degree rule, we can say this is 1 over 2. Y equals 1/2. This is our horizontal asymptote. So 3 is correct. Our answer is C.